Good day, everyone. This is my report about the implementation of white colored coating to cool a 30 square meter room. Introduction. Passive cooling is a building design approach that focuses on heat gain control and heat dissipation in order to improve indoor thermal comfort while using little or no energy. This method works by either preventing heat from entering the building or heat gain prevention, or removing heat from the building or heat removal, or this is called as natural cooling. Natural cooling dissipates heat by utilizing on-site energy available from the natural environment in conjunction with the architectural design of building components, like building envelope, rather than mechanical systems. As a result, natural cooling is dependent not only on the building's architectural design, but also on how the site's natural resources are used as heat sinks. The upper atmosphere, outdoor air, and the earth or soil are all examples of on-site heat sinks. Passive cooling is an important tool for building design for climate change adaptation, as it reduces reliance on energy-intensive air conditioning in warming climates. The figure is a traditional Iranian solar cooling design using a wind tower. Passive cooling strategies. Shading devices. Shutters, awnings, canopies, blinds, and projecting horizontal and vertical panes are examples of external shading devices. Because the absorbed heat is dissipated externally, these sun controls are the most effective all for reducing solar radiation when properly designed. Double glazing. Double glazed windows are an excellent choice for energy efficiency and noise reduction. The air gap between the two panes served as an additional layer of insulation. This increased thermal resistance reduces heat loss in the winter and keeps your home at a more comfortable temperature. Natural ventilation, wind catcher, and cross ventilation. According to use, wind catchers are old designs that were once used to bring cool air into a building. Natural ventilation is an effective way to save energy while maintaining a healthy indoor environment. Green roofing. A green roof system is an addition to an existing building's roof that allows for the growth of plants. The plants may be modular or have drainage layers depending on the type of green roof you install. To keep the structure safe and undamaged, all green roofs include a few key features such as waterproofing and root repellent. Insulation. To reduce heat loss or heat gain throughout the building envelope, passive design must include insulation. Insulation acts as a heat flow barrier, reducing heat loss in the winter to keep the house warm and heat gain in the summer to keep the house cool. Evaporative cooling via fountain. A fountain can cool the air by combining with water and evaporating, resulting in a decrease in air temperature. To get the most out of this method of cooling, the interaction between water and air should be as widespread as possible. Indirect radiant cooling. The radiant cooling was used in an additional attempt to cool the temperature of the roof. Radiant cooling occurs as a result of the net emission of the electromagnetic waves from warm to cool objects. Light color coatings with high reflection. According to Shen et al. 2001, exterior walls exposed to a solar radiation can transfer a large amount of heat to a building, affecting the temperature of interior spaces and decreasing comfort level temperature. To reduce heat transmission, solar reflective coating can be used to lower interior temperatures in addition to cooling loads. Methodology. The materials needed in the Arduino setup are Arduino Uno R3, LCD1602 module with pin header, DHT11 temperature and humidity module, and jump wires. The schematic diagram of the setup is shown at the right. After setting up the Arduino, code has been uploaded in order for the DHT11 temperature and humidity module to function. After uploading the code, it was checked in the LCD1602 module if the temperature and humidity were displayed. After troubleshooting the errors, the setup was ready to use for the data acquisition. Data acquisition. Below are the data obtained from the Arduino setup. From 11:30 p.m., the temperature is 30 degrees Celsius and the humidity is 81%. For 12:30 a.m., temperature is 30 degrees Celsius and the humidity is 80%. For 1:30 a.m., the temperature is 29 degrees Celsius and the humidity is 81%. For 2:30 a.m., the temperature is 29 degrees Celsius and the humidity is 84%. For 3:30 a.m., the temperature is 29 degrees Celsius and the humidity is 87%. For 4:30 a.m., the temperature is 29 degrees Celsius and the humidity is 84%. For 5:30 a.m., the temperature is 29 degrees Celsius and the humidity is 84%. For 6:30 a.m., the temperature is 29 degrees Celsius and the humidity is 86%. For the 7:30 a.m., the temperature is 29 degrees Celsius and the humidity is 86%. Implementation of white-colored coating to cool a 30 square meter room. After the implementation of the white-colored coating to the room, it is expected for the room temperature to reduce by 5 degrees Celsius. That's all. Thank you.